Welcome everybody today's webinar. And I will go ahead and start with an introduction here. And today's webinar, the session is a new and innovative workflow to increase drilling accuracy using PPK drones and GPS smart drills. And today's presenter are Robert Klau from Klau Geomatics and Kris Jeremiah from Aggregate Resource Industries. So just to set what we're going to cover in today's session, here is the outline for today. We're going to have introductions about each of the companies here, and we'll dive in directly into what is PPK. A lot of the time, these are just abbreviations and terminologies that's hard to understand. So we're gonna uncover all those details and also the difference between the PPP, GCPs, and RTKs. Why is it beneficial one or another? We're gonna cover very detailed workflow of how you can use PPK drones in drill plan design. And then the workflow from start to end for the data capture and the best practices around. How you can send the drill plan to the GPS smart drills or your rover that you are using for the layout. Also, how this entire workflow is just one-stop shop where you can just upload the data and the processing is done for your drill plan. And then finally, we will also review a case study, a real case study that has been seen and observed the benefits of implementing the PPK systems and how it improved various outcomes that's led from the drilling accuracy. And then we'll also review the ROIs that has been achieved from this, and we'll launch the Q&A here. A bit more about Strayos. We were founded in 2016, and we are essentially a platform which you can process the photogrammetry data. And then we have developed various tools around it to support mining, drilling, and blasting workflows. We are present in 8 countries, and roughly 600 mines and quarries use our software, and around 50 plus customers. But majority of the KPIs that we love to talk about is how we are improving drilling and blasting operations, as well as the overall ore quality and yield here. We have a global presence. Our teams are based in different time zones in America, US, Asia, and Australia. So that gives us ability to do 24/7 customer support. And looking at what are the range of tools that we support and we have developed is all ranging from design, predict, and assessment, and then the optimization. So that's how the entire life cycle of the drilling and blasting, as well as the mine optimization workflow we cover. So on the design side, if you have the data from the drones or pictures from any camera data, you can upload and generate 3D models. These are survey models that can be applied for any type of designs, like drill designs, face profiling, data analytics. And then we have loading and timing design tools that which you can apply to use and predict fragmentation. Along with that, also understanding of the shape of the muck pile, vibrations, or anything, the structure maintenance side that also can be predicted here. Then we have also the geological and geotechnical analysis tools, which we call rock mass AI. It's been there for understanding of the geology. And the assessment part is after the blast has happened, you can assess fragmentation, rock on the ground, particle size information, your muck pile movement, and heave assessments. So that's a big part of the performance assessment that you can build to track several KPIs for your blasting parameters. And then also, if you have the drilling log data that you're collecting from the smart drills, you can bring in to assess and visualize in 3D the hardness and softness of the rock, along with the borehole deviation measurement data here. And then the optimization side, once you have all this data, you can run several optimization techniques as an analytics. So optimization, identification of different design parameters, optimal powder factor, a multivariable optimization that you can run on this system. And all this is a power, what we call the AI that helps not only organizing and leading to much more accurate models, but also this is giving you another better decision making scenarios and running what if scenarios analysis here. So that concludes Strayos' introduction. And for today's session, I think it is important to do a more of a preamble or setting up the scene here. What we're going to talk about is essentially the digital drill plan pattern design and fragmentation is one of the important characteristics of any type of planning that you do. And not only that helps assess various environmental or fly rock conditions, but also it's an important part of making sure that drill planning is done in a compliance way. However, the traditional survey workflows like using the survey equipment, which are GPS equipments for every shot, it's very impractical because time consuming, and there's all sorts of points that comes with it that makes it difficult to do it every time. But with the PPK drones, now we have kind of optimized this digital pattern design to take care of this workflow in minutes. So you can fly over with a PPK drone over a bench for 5 minutes, no base station requirement, no GCPs. On top of that, you're getting the very accurate data along with the pattern design that you can do and the data processing under 45 minutes. And then optimization of pattern can be run to get your accurate drill hole positions, and then that can be further transmitted to the smart drill or your rover or any other devices that you have for the direct layout here. So no reformatting required. You can use the rover if you have the rover, or you can also use the tape measures as well. Since now you have the accurate hole locations, you can easily measure to lay out the holes as well. So that's the initial setup for this today's session, and we'll go into more detail about each of these points, how it actually works. So with that, I will introduce our today's speaker. Kris Jeremiah is the president of Aggregate Resource Industry. As a president, Kris leads operations, new technology innovations, and technical services engineering work to support their customers in 12 states. And Kris has 20 plus years of experience in drilling, blasting, and mining industry. And he has a degree in mining engineering from the University of Idaho. Rob Klau. Rob has 35 years of international experience as a consultant, contractor in mapping, geodetic surveying, photogrammetry, and exploration. He's a founder and director of Klau Geomatics, a successful surveying company now manufacturing the Klau PPK, GNSS, and IMU systems, which is a totally integrated platform. He founded, grew, and successfully exited a UAV mapping company. And Rob has a solid domain expertise and a broad perspective on the geospatial industry, which you will hear from him on that facet. He also holds a Bachelor's of Surveying degree and ESP, AP, SSSI certification. Probably, perhaps, Rob, you have to explain what that certification is. So with that said, we'll launch into our first poll to transition into our speakers here. So let me kick off polls here. If you can participate for a few seconds. Hold on, I think this is not the poll. poll number one, which is essentially how much of your drill plan design work is currently digital. So we'll take a few seconds. Great. We'll wrap it up in last couple of seconds. Great. Rob is back here. Perfect timing.
Excellent. Thanks.
Well, thank you very much. I think there's some mixed responses here in this one. We'll continue with our the next part of the session here. So I'll let Kris introduce ARI, and we'll get it rolling.
Good afternoon, Ravi. Thank you for the introduction. Again, my name is Kris Jeremiah with ARI, and we're Springfield, Oregon-based drilling and blasting contractors. Our family started the company back in the late 70s and basically grew up in the drilling and blasting business, and then went to the University of Idaho in mining engineering, and now running our operations here. So our primary work is drilling and blasting for quarries, gold mines, silver mines, heavy highway construction. And so we run a wide range of drills from small diameter, like 3-inch diameter holes, up to larger diameter, like 16-inch diameter DTH rigs. So anyways, we have a wide range of rock drills that we use in multiple different industries, but the focus of most of our work that we're talking about today is in the mines and the quarries and the highway and development work. And we've implemented the Strayos design along with Rob Klau's PPK drones, along with our smart rock drills, and basically just kind of wanted to talk about the evolution of how we've adopted the technology. We first started to bring in the smart drills in about 2018. We brought in some EpiRock smart drills, and we were using the GPS technology on the smart drills. Ravi came in and met with us in 2019 and showed us about his program with Strayos, and we started to design most of our plans for our drilling and blasting in Strayos. We were doing most of the design work with like Mavic Pros and Phantom 4 Pros, and using Rovers to grab our ground control. And Ravi started to talk about the Klau PPK system. And so we contacted Rob and basically brought the Klau PPK system in to try to condense the workflow process and just get more accurate, repeatable information. And so now we're working with a good percentage of our flights are flown with the Klau PPK. We still use some of the traditional rovers and drones to get the data, but the Klau PPK is what we'll focus on today, and just showing our workflow. And we'll get into more detail later about how we actually set the drone up and do the flight. But basically, the main reason that we implemented the Klau PPK is it's a very condensed package that we're able to bring to the sites without carrying extra tripods, extra rovers, base stations. It basically all comes in your drone package, self-contained. It's very user-friendly, and the accuracy that we're pulling off of these drones is very repeatable. We can do the same flight and get the same accuracy time and time again. Whereas with our rovers, when we were getting ground control, sometimes we would have some inaccuracies in gathering that rover data for our ground control. And so the Klau PPK has allowed us to use a simple system that's very accurate and very reliable. Minimal setup time when we come out to the project. Like Ravi mentioned earlier, we can collect all the data within 15, 20 minutes, get it uploaded, and then it's back to the drills. And within a couple hours, we actually can be drilling holes from the time that we show up to the site. So again, I wanted to talk about the reliability and repeatability. The PPK seems to be bringing better imagery when we're looking at it versus the RTK imagery that we would get. And I think Rob can talk about that in a little bit more detail. We don't seem to have areas where we don't capture the imagery. It's very consistent. The other nice part about using the Strayos and Klau PPK is when we gather the information and we send the Klau PPK data to Strayos and the imagery to Strayos, they collect all the data, they process it, and there's very little user interface once we've collected the data. So that's been very helpful for us. And once all the data is processed in Strayos, we build our drill plans and we're able to email that out to the drills, the smart drills, or to the Rovers for the not so smart drills that we have. It's just Strayos has basically worked with Klau and the systems that we work with, Epiroc and Trimble, to have a pretty seamless export process back out to the field. And then one of the other benefits that we've seen, if like on areas that we're trying to access that are difficult for people to climb around with a rover and get ground control points, with the Klau PPK, we can get the ground control down below and we can fly the rover, and we don't need to have multiple ground control points throughout the project site. We can actually get the ground control from where we launch the drone, and we're not putting people up on multiple benches trying to gather the ground control. So those are some of the benefits that we've seen, and a little bit later I'll go more into the actual process of how we set up the drone and what we do to gather the data.
Yeah, thank you, Kris. So time for another poll here. So we will launch it, the second poll. So if you can indulge in that. So what level of GPS and drones do you use for your drill plan surveys? So interesting responses. So it seems like everybody is moving towards GPS for sure. We'll give it a last 5 seconds. Great. Yeah, so very interesting response here. So we'll close the poll. Thank you, everybody. So this is the perfect segue here to introduce, Rob's, Klau Geomatics system here. So I'll let Rob kick it off.
And I didn't hit the exit button that time accidentally, so I'm with us. So yeah, thanks very much. And Kris has sort of given you a bit of an overview of the sort of user experience and his, the value he sees out of our products. So I'll just go into a little more depth because surveying and drones and digital twins and all this could be a bit foreign to our audience who are more familiar with the drilling side, so drill and blast and so on. So Klau Geomatics, we build accuracy solutions for, a lot of it is for drones, but we also support manned aircraft for aerial mapping. We have an integration hardware platform that connects to other devices, so you can use our system with various different inertial measurement units with LiDAR scanners. We've done various applications in civil construction for augmented reality and offshore tidal buoys and all sorts of things. So we have quite a broad spectrum of hardware, but it's more about the connectivity and the integration capacity. It also, that same concept carries over in our software as well. Make It Accurate is a system we've developed that is what we've integrated in with Strayos, and that essentially you can take quality drone data with good GPS data log there, send it to Make It Accurate, and it does exactly that. It makes it accurate, so you don't have to worry about those survey base station issues and all the rest. So it's really designed for enterprise solutions like Strayos. So just so you know, that's where we're coming from. We're not sort of really a single solution. We're a integration accuracy company. Ravi, yeah, thanks. So just a little, I'll just touch on photogrammetry. Won't go into things too deep here because it really is a dark art. But essentially what you're doing is you're taking overlapping photos, downward facing photos, they overlap, and you consider you've got two eyeballs in the sky like that little diagram. So when you project pixels from that point in space, you can figure out the height of an object or the height of your terrain. So it's essentially, as you look with two eyeballs, you see 3D. You do the same, but with hundreds of photos. That photo on the left, just by the way, this is where photogrammetry started out in the 50s. Big mechanical machines that physically did what we now do digitally with hundreds of photos to create your digital twin. So that concept is really being embraced in all sectors now, in asset management, insurance, linear infrastructure, mines, construction, pretty much everywhere you look now, digital twins are a thing. So instead of the mine surveyor or yourselves were, going out measuring volumes of stockpiles on the ground, you capture your digital twin and you do it in the office, and you've got that full snapshot of your entire site. So they're very, very powerful products. As for how you capture that, if Ravi, you want to flick to the next slide. So essentially you want to fly your drones over your site. It's really all you need to do. You could fly pretty much any drone and smash that data into some photogrammetry software, and you'll come up with a 3D model. And could be quite good, could be adequate, but you can create those 3D models with a lot of different software products and with basic drone data. The problem is accuracy. That's the challenge, is how to make it accurate and how to make it easy to make it accurate, because really all you want to do is fly your drone. So now the traditional way of doing it is with GCPs, ground control points. What this means is you've flown your drone, you've created a model, but it sits in space somewhere in the wrong place. So with these targets on the ground, you can identify those targets in your model, and you pull your model down and you fit it and you stretch it and you rubber sheet it to those control points on the ground. So what it means, you've got to travel your site to put maybe a dozen of these points across a typical site, and spread out evenly. So some of them are going to be in the bottom, below a high wall, on the top of a high wall, all sorts of places that you really don't want to have to go. You need survey equipment to put them in, because you've got to mark them on the ground so you can see those targets in your photos. You need a surveyor to survey them, or you've got your RTK gear, you've got to set up your base station, your RTK. Or there are those smart GCPs. So you just throw them out and they'll start logging data and you can process it and so on. But then you've got to travel your site again after you've finished your flight. You've got to go to all of those places that you'd rather not want to be and pick up those smart targets. So no matter how you look at it, it's intensive on field resources, safety and so on. There's a lot of reasons why you wouldn't want to do it. Also, when you come to processing, it can double the time it takes to process your photogrammetry, because you're going from these known points on the ground, and you have to reverse engineer where the camera was for each photo. So a lot more time goes into processing as well. And accuracy will be good at the GCP because you've locked your model down at those points, but in between you've got errors drifting in, and may or may not be that great. So that's sort of how things used to be done. Then you could use RTK. So now we're taking away a lot of the need for those ground control points. I wouldn't say you totally remove them, but we'll get to that in a sec. You need a base station though. So you need that base station to be logging, capturing GPS data and transmitting it to the drone. You need to know the coordinate that the base station's sitting on, and that might not always be easy. Probably in a lot of your quarry sites, you'd have some sort of survey control set up, but you've got to set that up. You've got that radio link, and your drone is now figuring out where it is in real time. But as soon as you have any interruptions to that radio link, or you start to stretch the range of that transmission, then your accuracy of your drone is going to fall away. The reliability, you lose lock, and it thinks it knows where it is again. Okay, I'm accurate again, and then a minute later it'll go, oh, hang on, no, that wasn't right. Now I'm accurate. So, it's a bit less reliable and less robust. So that's where we move to PPK. PPK is essentially very similar. The processing uses the same algorithm as RTK, but you're not trying to do it real time. You don't need real time accuracy in your drone. You just need to know where it was after the fact. So what we do now, we still need that base station. You still need to know where the base station is. So you need that survey mark that it's set up on. You'll see in that diagram, just above the base station icon, that's a cause station, if you believe my little icon there. So you could use a cause station that's in the region. You've got to then, after the fact, you go online somewhere, find your local cause station, download the data for the time period that you worked. So, and essentially, in the drone, it's capturing and storing that raw GPS data. So compared to RTK, this is much more reliable. You still need your base station, you still need your base station coordinate or your cause station. But because all of the data is logged on the drones and on the base station, you've got a complete set. There's no losses from radio link issues or flying behind the hill and you've lost your radio altogether and so on. You've got all of your data there. You process it forwards and you can process it backwards, which is really quite clever. So if there are any little glitches, it can pick them up on the way back through. So your accuracy of your camera coordinates in your drone are much more reliable. So it takes away a lot of the variables. So PPK is basically, we're saying it's a much better way of doing it than RTK. So that's a typical system that we at Cloud Geomatics supply for a lot of different drones and other devices. Just a note here, I realize this might be getting into kind of excessive technical depth, but those sort of triangles coming down from each drone, I just want to express here about the lens calibration on the drone camera. If you consider now with PPK, we have a blanket of control points above the site. So if you've taken 250 photos, that's 250 control points you've got now. You know exactly where the camera was. So they will all match together very nicely in your photogrammetry because you know where they are. They all project together and create your model really quite quickly. But if you have an error in your lens, if it's 35.001 instead of 35, then essentially it's a little bit of zoom. Consider yourself, you're those eyeballs again, looking down at the terrain. And if you put on your glasses and it changes that focal length a bit, essentially brings the terrain up or it pushes it down. So you're going to get height errors without a nicely calibrated camera. So with our cloud geomatics systems, we calibrate your camera. So essentially this means you don't need GCPs. I'm a surveyor. I'm not going to tell you, trust me, trust our thing. It's great, works every time. You do want to have a couple of checks on the ground. And Kris has mentioned how easy this is to do with our system as well. You can put your drone on the ground and take a photo, spray across with a can of paint. So you have a couple of checks. They're like GCPs, but you are essentially confirming that what you are creating in your digital twin does agree to some survey on the ground. As a surveyor, I'm not going to let you go out and just trust me. So anyway, that's just a bit of a mention about camera calibration, that we've got you covered on that. Now, this is where we get really, really clever. And this takes PPK to a whole other level that applies to corporate operations and people like yourselves. You don't want to have to know about base stations and control points and survey stuff. So in this diagram, you can see where I had one cause station before that you could have possibly used for your PPK processing. If you're doing normal PPK, that any control point would need to be within, say, 20 miles to get really good results. What we've done now, those other icons with those big dishes, they represent the GPS tracking stations around the world. So what we do with our Make It Accurate solution is, after the fact, after you've flown your job, we get the precise satellite orbit information and the clock corrections, because GPS is all about timing a signal that leaves a satellite, comes to the ground, to your receiver at the speed of light. So we're talking about cesium clocks here. And so we get the very precise clock corrections and exactly where the satellite was for each epoch, each little transmission from every satellite. We apply all of this data. We also, in the US, this works really well. It works great in Japan, US, Australia, New Zealand, and parts of Europe, is that we pick up to 15 cause stations, and they could be 100 miles away. But we bring this into the whole processing algorithm and with the precise clock and orbit corrections and 15 cause stations, we get you back to that same kind of accuracy that you would be looking at with your own base station, a local base station. So essentially 3 centimeter accuracy in those countries that I mentioned. In other countries on Earth, we've got some people in parts of Africa and all around the world where we can't tap into that cause network. You're still looking at about 7 centimeters, possibly 5 to 7, somewhere in there. So it's still pretty much your RTK survey accuracy, and there's no base station there. So, so this is actually it's an incredibly powerful system. We've integrated this with Strayos, so that processing engine is directly plugged into the Strayos system. So you upload your data from us. from our drone, the data off your drone goes straight to Strayos. At Strayos, it through the API connection hits our Make It Accurate processing engine, gathers up all of that data from around the world and that cause network and so on, and your drone is accurate. So it's a very complex system, and also those camera calibration parameters are applied in there. So that's the complexity of it. But Ravi, if you want to go to, I think it's the last slide now. From your point of view, as Kris mentioned, go to the field, pull your drone out of the box, fly your drone, upload your data. That's it. So you don't need to know all of that complex stuff that's going on in the background. We've got you covered. We've handled all of that. And with Strayos integrated with the Klau PPK, the Make It Accurate system, it's just magically accurate and incredibly simple. So that's kind of the that was what we were out to achieve, and we got there. We've got an incredibly accurate, simple solution. So you can erase from your memory everything you just heard in the last 10 minutes. You don't need to know that stuff, but just know that we've got you covered. So that's about it from me, I think.
Yeah.
Leave it to
Thank you, Rob. And I think now it's the time for another poll question here, which I will momentarily launch, just to get some inputs here about what are your main blockers for not doing surveys for every drill plan. So definitely, I think the time-consuming part, which is the big thing for most everybody. Again, the base station setup is something, it's a big problem, as I see here. So we'll give another last 5 seconds. Well, I think, yeah, it's a mixed here. Definitely no base station setup is a big problem, it seems like. Great, so we'll close the poll and we'll transition back here to the next phase of the presentation. Yeah, so here we're gonna review the workflow that Kris has, and he applies that on the field for his job site. So I'll let Kris walk through.
Thanks, Ravi. So just kind of to reiterate what Rob just mentioned, now that Ravi and Rob and their teams have worked together to reiterate the process, it's seamless, it's simple. Basically what we do, we show up to a site. If we don't have a flight plan already built, we build a flight plan for the bench that we're going to be working on and drilling. We go out, we put basically 2 marks down with either some white paint or some light blue paint, something that the rover is going to see in the imagery that we collect. We turn the drone on, or the controller on, and the drone on, calibrated if needed. We make sure that we put the USB stick in Rob's in the Klau data collector. I have to admit, the first flight that I made with the system, I got all the flight done and I was excited, and I didn't have any PPK data because I didn't put Rob's USB in his data collector. So please put the USB stick in. And so basically, you let the drone sit for probably, depending on the clearance to the sky, probably 5 minutes to 7 minutes to let the drone collect all the satellites. And I don't know exactly how many it needs, 12 to 15, something like that Rob mentioned. So that's probably the most time consuming part, is just waiting for the satellites to lock on to the Klau PPK. And once it says okay, you launch your drone, collect the imagery. When it actually, I'll back up just a little bit. before the flight, once the drone, the PPK has said that it's locked onto all the satellites, we take 2 ground points. You can see in the underneath the data capture there, it says before flight. We take 2 pictures of the first ground control. That one actually has four pictures there, but take 2 pictures of the first ground control point. Then we launch the drone, do our flight. Once the drone comes back, we set it back on the first ground control point, and we let it sit there for about 2 minutes just to make sure that all the satellites are back and connected to the drone. We take 2 more photos post-flight at the first ground control point. Then we walk over to the second ground control point that we've marked out and take 2 more images after it's set there for 2 minutes. Once we've done that, we shut the system down. We remove the USB stick from the Klau PPK data collector, remove the SD card from the drone, go back to our laptop or computer, upload it to Strayos. And it's very simple. Previously, when we were collecting ground control points, sometimes we would get field information that was misrepresented in northing or easting. We'd get some data entry errors, and so you just don't have that with the Klau and Strayos system. There's basically no user data that you input into it other than the USB stick and the SD card. So then it probably takes 45 minutes or so to upload and get turned around. And there's I don't know, I think on the next photo, Ravi, yeah, let's see, might be in another one here, but the accuracy that we'll see is, I guess I would say, probably within 3 to 4 inches for the most part that we're seeing. Basically, we can see here the drill plan that we've established and built. And then we either export this out to our drills. And again, we run the EpiRocks for our smart drills. So we just upload that into a system called Certique. And then it goes directly to the drills. And for our not so smart drills, we've got Rovers out in the field. And Strayos has worked with Trimble to export right out to our Rovers, so we can email right to the tablets out in the field. So it's a very seamless process that Klau and Strayos has put together to basically you fly your site, build the drill pattern that you want, and then it exports out to your drills or Rovers, and it's been a nice process to work with.
Yeah, so just to kind of more expand onto this, how Strayos takes care of the processing pipeline here is, again, just behind the scenes here. So Strayos collects the binary kind of GPS information, and then also the pictures that is getting uploaded by the users. And these images have original GPS information that's collected by the drones, but then we pass on the request to make it accurate API. This API runs the request. It goes and consolidates the actual accurate GPS position for all the images, sends it back to us, and then we have that exact centimeter level accurate positions of each images that we store and send it to our photogrammetry processing engine. And now you have the photogrammetry results ready to go. So as you can see, the accuracy is kind of, sub inches. That's how most of the PPK processing that has been, we have seen. So the workflow is fairly simple. All you're doing is just flying your drone, no base station setup, and just uploading the PPK data and imagery to the system and getting the model back here. One more thing that I would like to highlight here in this slide is the PPK drone itself can become a rover. Essentially, when you are taking this ground control point pictures to verify, this is your, you can hover over your drone itself, to collect it, or to double check as well, you can bring your rover as well to verify. But I think it's most of the time you can utilize your rover drone itself, the PPK drone. So we're going to look into the case study because this is an interesting one to talk about, and I'll let Kris kind of walk through this case study for his one of the sites. Oh, Kris dropped as well. Oh, interesting. Hold on. Oh, Kris is back.
Sorry
yeah,
about that.
Kris, do you want to walk through the case study here?
Yeah, real quick, this was a project down in Southern Oregon, a quarry that we've worked in over the last 20 plus years. It's an extrusive igneous basalt, and it's fairly blocky, fairly large joints. And so historically, we've had some oversize issues there. And so I guess this is probably the first time where we put everything together. We put the drone survey together. We put the Klau information together. We put the utilization of the smart drills together and the Strayos optimization of drill hole placement. And so this was kind of our aha moment of where everything came together, and we saw improved fragmentation, reduced drill hole, reduced holes because we weren't putting holes in places that they weren't needed. So anyways, this is the where it says the comparison down in the bottom right. I don't know if you can see the accuracy, that's down in the bottom, but it's a little difficult to see. But anyways, sub 6-inch accuracy right there. And Ravi, is there a video on the next one?
Yeah, so for this exact same site, the blast that has been executed here.
So overall results on this one, the customer saw improved fragmentation. We didn't have fly rock issues. Just so for this particular site, it was a good overall results that that we were seeing from the combination of all the data that we were able to bring together and execute in the field. So as far as the return on our investment for purchasing the Klau PPK, basically one of the things that we found is reduced time laying out holes when we're using the smart drills, much quicker setup time versus laying out either the ground control points with the rover or with the electronic ones, with the arrow points that we've used in the past. And then basically just the overall drill layout is expedited from just having to lay out with regular tape and paint, which we've done there the last 20 years. One of the things that we're seeing is we're actually drilling less holes because every hole is put in an optimum location. And so we're not drilling holes just to pick up a toe, and load the bottom 10 feet of it. So I think we have actually reduced our drilling costs because we're not drilling unneeded holes. And then just the ability to optimize the hole placement to minimize fly rock and maximize fragmentation. So, and then overall, the customer's happy because they have reduced processing costs. So.
Yeah, and Brad, I'll let you jump into kind of to the ROI breakdown here, which I think it's very interesting to kind of understand this.
Yeah, for sure. So I guess this is just an example of one way you could calculate ROI. Say you were a site who was thinking about implementing this. All you have to believe is that you really can reduce that drilling error by 1 foot in standard deviation, which is fairly realistic. Like based on industry standard modeling, you could get about a 5% improvement in your fragmentation, leading to around that 5% savings on crushing costs, which if just assuming a kind of a $10 million per year spend on the plant already gives you $500,000 in value per year, which is ROI of 900 to 1,000+% already just on in that kind of example case. So from a site perspective, when you consider all those downstream savings and impacts that you get, it's a no-brainer to start controlling your drilling and your drilling design more robustly. So great. I think that's it for the content that we have. I guess we have one more poll to launch just before we jump into questions. So if we look in the chat, you've got your poll 4 down there. Are you considering implementing PPK drones in drill plan surveys? So yeah, keen to hear from everyone if this is something that's on people's radar. Is it something that thinking about doing soon or thinking about doing maybe later? What's the general consensus on people's sentiment? Cool. So I can see these numbers bouncing around as they always do. We've got a few people who are looking at bringing it in pretty soon in the next 3 months, and some I guess the majority of people who are quite interested but not sure when they could bring it in. So I guess for the people who are interested in the next 3 months, obviously feel free to reach out to us and Rob. Straight away if you are interested. People who are not sure on timeline, feel free to throw any questions that you might need answered in order to get more clarity on that into the chat now, and we'll jump over there to have a look at some of the questions.
Yeah, I think we have already a lot of questions here, so we can take. I know we have 5-6 minutes left to end the session here, but we'll jump right in with the questions here. So based on the votings here, so the first one is, what is course station? So Rob, do you wanna take that up? Yeah.
Station. So essentially, it's a GPS receiver being run by typically a government department. They log that data continually, and you can go online, log in, and download some base station data. So that's how we use cause stations. In the US, there's NGS NOAA has a network, but then there are probably 50 other networks. A lot of Department of Transport networks and state government networks, and there'd be hundreds probably. Even local governments can have their own cause. So that, and actually mine sites for that matter, you could almost call theirs a cause, even though they're not, say, publicly available. Some you need to have an account to get to the data, and you pay $1,000 a year to get it. Others, like NGS, is free. So we've got some integrations directly into some cause networks in our Make It Accurate system that makes it more accurate.
Great, thank you, Rob. There's another question here. So within the new workflow, who designs the blast plan? I think, Kris, you wanna take that up?
Yeah, we design the blast plan generally here at the office. Either one of our engineers or the manager of the project designs it. So, and then we have a review process that it gets approved by either myself or the blaster, who's going to be in charge of that. So, but we do it internally here.
Great, thank you, Kris. There's another question here, more related to drones. So would drones with the 3D capabilities such as Skydio enhance this data or make no difference? So I believe, Rob, you can take that up as well, and I'll expand on that.
Sure. I'd have to take a look at the Skydio drone and what we're talking about there. About 3D capabilities. Maybe we're talking about a LiDAR drone.
Yeah.
So at this stage, the integrated system we have set up is a photogrammetry system, which is a more accessible way of using drones to capture 3D models. We do support a lot of different drones. So I guess I'll leave that question a little bit unanswered and open, but just with the fact that, yeah, the Klau PPK system can go on various drones with various cameras. So in some cases, that little Phantom 4 Pro is easy and accessible, and it's small, and you can put it in your carry-on a plane. Or you might want to take a larger drone with a phase 1 aerial camera or a Hasselblad camera and fly higher and bigger. So a lot of variables, but I would say that we get back to me if you like. We can get to the details.
Yeah, absolutely. There's one more question here. Have you considered incorporating geochemistry data, also known as ARD, assay characterization in the workflow for segregating material and improving blasting efficiency? So I think the answer is yes, of course. We can process the hyperspectral imagery data as well, which can get the mineral classification, as well as the characterization of different types of signatures. There's just one more question.
The platform's also set up so that we can import data, any type of data captured in the field from assay sampling.
For sure, yep. There is one question here. How does drone profile accuracy compare to the laser profiling? And I think Brad or Rob, or perhaps probably Kris, you could answer it more, since you have used both. So
Last perspective, the 3D drone imagery is much more reliable than the laser face profiling from our perspective, because we're actually getting a 3-dimensional profile of it versus just where we've run the laser down. So from our perspective, the drone's given us much better information.
amazing. There's one question here. Can we mount this Klau system to a Phantom drone to improve the accuracy quality? So that's the question, Rob.
Yeah.
Can they mount the Klau system?
Yeah. That's right. Yeah. That's kind of our very popular accessible drone is the Phantom 4 Pro. So yeah, there's a mounting kit for the Klau PPK to go on the Phantom 4 Pro. We do need to modify the camera because we tap into the shutter to get the very precise timing from the shutter. So we would take your camera, modify it, and then that's the point where we calibrate your camera as well. So then your camera calibration data goes to Strayos and gives you that best possible 3D accuracy. So yeah, Phantom 4 Pro is an awesome drone for this.
Well, I think we are almost, over time here, 3 minutes, and I certainly don't want to keep longer. I think in US, almost the day is getting wrapped up, and of course, Australia is getting started. But this is the wrap up for now. We will answer the remaining questions over email. So, keep an eye out for that. And also we will share the recording as well. And if you need a certificate for the attendance, please email us back. We will get that organized for you. I want to thank everybody in the audience for joining in today, and for such an engaging questions and all. Yeah, it's always great to hear the audience perspective. And also, if you want to recommend a topic that we should cover in our next webinar or session, please let us know as well. We'll include that. And I want to thank our today's speaker, Rob, for getting up early and doing this, and Kris for being amazing to share your insights on how you have implemented this workflow. So thank you very much for being an amazing speaker today, and thank you, Brad. With that, we'll wrap this up here. Thank you, everybody.
You.